So this is not a talk on trout fishing in Canada, even though it looks like it. So we're going to talk about building a chatbot using GenAI. And since the previous session, if you were in a previous session just a few minutes ago, there's a lot of there's a great speaker, talk about RAG techniques and GenAI. I won't cover some of the same material, but I'll give you a wider view. We'll build a chatbot, I'll show you a demo, but I'll give you a wider view how this is even just beyond generating code, way, way beyond generating code.
Is your microphone not connected?
The reason why, here you go. Can you hear me? Okay. Is that okay? People in the back, could you hear? Okay. All right, so we're at the start of a long tail process, right? Of course, we all read about GenAI, ChatGPT. I mean, it's, I think my email, the spam that I get in my email, I think every other spam email is GenAI. So it's getting a little ridiculous, but it's going to be a pervasive tool, right? It's not going to replace your jobs, but it's going to be a very powerful tool, right? And we're going to learn about chatbots, because if we understand how chatbots work with an LLM, you'll understand the big picture. So I want to give you the big picture, and then if you want, like I'm more interested in the vector database, I'm interested in RAG techniques, I'm interested in prompt techniques, then you can follow up and dive down deep. So I'll give you the low fidelity view, and then you could increase your fidelities as you go forward. So it's important for all developers, not just Java developers, for all developers to understand this, because it is a valuable tool, and companies are hiring for this. This is a 10 to 15-year trend. It's not a trend that's going to die, in a year from now, and it's not a trend as some pundits saying, oh, there's going to be a bust, a .com like bust. Well, no, that's not true either. Okay, so it is a powerful tool. Right? And we know about tools like, a reactive framework comes out. This is cool. Okay, it can simplify the way we do distributed asynchronous code. Okay, it's cool, but it's kind of bad. It's, at handling exceptions. But here's LLMs. We can use it with some cool ideas. But what's the downside? We can destroy humanity. So it's a different type of framework, different type of tool. So this is not just like another framework to learn. So let's take a step back to understand what is all this about? And now I gave this slide last year here at Devnexus. So how many people were here last year in my talk? Well, that's good. Only a few. Then I got to repeat the whole thing. So there's a lot of patterns in nature, and a little bit about my background. I'm a musician, like most of you. Like a lot of people love music, and I know we have some musicians in the audience, that there are patterns when you play music. Like I can go to a musician, we have some musicians over here, so I can tell Gail, I can say, we're gonna do a 1-4-5 in the key of A. And she knows what that means. So we can play together. So there was like, what was that all about? That was a pattern, right? And it could be a jazz pattern, 2-5-1, if you know about jazz. That's a pattern in jazz. If you play football, whether it's American football, where we don't use our feet, except for field goals, or soccer. I know I said the word soccer. But you know about patterns about the defense and the offense. How do you play your offense against that defense? Well, what's that all about? It's about patterns, right? And in nature, how do animals know where to get their food? By patterns. And so I actually I studied astrophysics in school until I found out that I had to work at night, so that quickly changed. It turned out I wound up staying in the lab all night doing computing, so it didn't matter. But when stars start to pulsate and they become chaotic, and then they blow up, and they become more stable, right? And I looked at software, I said, that's how Unix was, and how C was, and how early make systems, they got chaotic, and then they blew up and something came by. Where did Java come from? It's like, well, it's a similar pattern. And then we know, like, we have Elvis, or we have Kurt Cobain, or The Beatles, why were they popular? There was something happening before them that caused their popularity. Of course, they're excellent musicians, but there was an environmental thing. There's a pattern. So, and unfortunately, I had the opportunity of working for a company, Lehman Brothers. You may have heard of Lehman Brothers. I was there a few days before they went belly up, and I have a lot of stories about that. But their patterns are everywhere. They're everywhere. So machine learning, it's all about patterns and whether you're predicting something or you're generating something. We have predictive AI and we have generative AI. And we have this gentleman in the 40s. He was sort of like a Bill Gates, Steve Jobs, like smart people, but they can be a-holes at times. so this was Norbert Wiener. But he said something very interesting. Before there was AI, he said the world is considered to be made up of patterns. This is before AI. Okay, of course, I said it's the universe since it's my seminar. I can do what I want. And I know that in astronomy, this happens too. So if we look at the big picture, so we have AI, and AI has been around for a long, long time. And on the right-hand side, we have expert systems being around for since before the 80s. Knowledge systems, knowledge graphs, symbolic AI, all that good stuff. And now we have a subset called machine learning, where, as the term says, the machine is learning. So you have to train it. That's what the word learning, it's the training process. So there's another subset called deep learning. So now that we have sophisticated data structures, we have neural networks, we have collections of neural networks, we have cloud computing, we have a lot of sophisticated computing resources to use. So that's deep learning. Of course, in the regular press, no one calls it deep learning. I mean, we're the smart people on the planet, so we have to know that difference. But it's really deep learning, but everybody calls it machine learning. And outside of semi-scientific, people call it AI. It's sort of not exactly correct, but so it's really deep learning we're talking about. And there's two basic types. There's the trendy generative AI, which we've known about from past year and a half, I guess, is most popular with OpenAI. Then we have predictive. So my colleague and I, Zoran from Serbia, so we have a JSR for visual recognition. It's a JSR for Java developers. It's not former libraries, or other libraries, I should say, are like C libraries. Yeah, you can call them from Java, but you have to pass like 25 parameters. That's C programming. That's what I did way back when in Bell Labs. That's not Java. So we created a real Java API for classical machine learning, for predictive AI. Okay, but we're going to focus on generative AI since that's the trendy thing. Okay, so I started looking around okay, I know about patterns. I'm a big pattern person. I mean, my graduate project was looking at patterns in music and generating new melodies, but in that style. So I was doing GenAI before, way, as you can tell from the color of my hair, it was a long time ago. So, but if you look around, you see all these different words: sentiment, propensity, riff, groove, character, penchant. What are all these words saying? That they're patterns. That we are all patterns. It's like when I saw this, I got a cold chill down my back. These words are all patterns. So wherever you see patterns, this is an opportunity for the good guys and also the bad guys. So we have to be very, very careful. Now, as software developers, where do we use generative AI? Okay, well, here's the traditional things. Oops. I lost my voice. Sorry about that. So if you look at all the basic areas of software development, whether you're doing requirements analysis, or you're writing code, or you're deploying something, you're doing maintenance, if you think about it, each one of those is a collection of patterns, right? It's like, wow, that's pretty cool. And then when you're not doing techie stuff, you're searching for info, right? Or you're solving a problem. You go into a meeting, there's emails, there's somebody's texting you, like status reports, right? But all those have patterns. So patterns are everywhere in the software development process. I mean, you may have read about, okay, well, GenAI is going to generate code. That's the tiny part. GenAI is going to take over everything, everything. And we have to be aware of this. We have to use it as a tool because it's going to make our life way, way better. So it's not going to take your job. Somebody that knows this stuff may take your job, but it's not going to take your job. Like an IDE didn't take your job, right? It's a nice tool to use. Okay, so how do we learn what's going on? So I have a class that I teach how to build a chatbot, a 2-day course. So I'm going to try to compress that into the remaining 30 minutes or so. Okay, so let's build a chatbot, because as I said before, if you understand how a chatbot works, then you'll really understand what an LLM does. Okay, so we're going to talk about neural networks, and I'll show you that basic diagram that everyone sees. Talk about engineering and some APIs, and then we'll talk about how do we improve the results. Okay, so some of the low-level stuff. Now, this is important. I know sometimes like, I don't want to know about the background, but it's important. So language models go back to the 40s, right? I'm sorry, pardon me. Let me correct that. NLP goes back to the 40s. Okay, language models came out in 1991. Okay, natural language processing is old. It's 1940s. And then in 2017, we had this huge breakthrough, because prior to 2017, we had language models that were sequential. To train a model back then, before 2017, it was sequential. With the transformer architecture, it was a novel way of looking at words, but one of the key things, especially for us techies, that it was parallelizable. So we can train a lot faster. That was a big thing, especially to us engineers, right? So, and also this is from Google, and Google actually patented this thing. So you can look at the patents. Google has a patent in this, which is an interesting weapon to use, as most companies use patents these days. So the world changed after this. And of course, with ChatGPT was a web app, right? It was a very simple web app. Just like when Google came out, it was just a simple text box. It was simple. When ChatGPT, it was simple. It made it easy, right? So what's the number one thing of user satisfaction? Make it simple. Make it simple, right? The principle of least effort. It's a well-known thing in psychology. Principle of least effort. Sometimes you write software and the users use it in a way that you never expect. I never knew you can use my software like that, because it was easy to do it in a certain way. Okay, so the first artificial neural network came out before the invention of the subroutine. That's how old it is. In 1943, by these two gentlemen. They were proteges of Werner in the 40s. It's kind of sad because Walter Pitts was a genius. He was a genius, and he had these visions of neural networks like we have today in his head, and he wanted to build it. And then unfortunately, he died before he was able to build it. And there's a link down there. It's a really funny link, but if you can follow that link, it tells you how skinny dipping slowed down the advance of AI. So that's an interesting link. I'll leave it at that. I was like, wow, it's funny and sad at the same time. So we know this picture of a neural network where you have inputs, and inside there's all these different layers. Then there's weights. So when you have an ML system, there's the training phase, and then there's the inference phase. There's two phases, right? You create a file, then you use the file, right? So you're creating a model, and then you're going to use the model. So as the data flows through this data structure, this neural network, it creates weights. What's more probable than the other ones, the paths, right? And then it's a very large multidimensional array. There's a representation of that using something called an embedding layer, where it maps this massive data structure or collections of data structures into a vector, a one-dimensional vector, which is, I guess that's redundant to say that. It's a vector, right? So as you put more and more data into this, the weights get, what's stronger. Well, these words are more probable, you go down that way. The least probable, don't go that way, go here. This is like, what's that game that, a pachinko game, right? We have the ball drops down and it goes ding, 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 ding. Well, if all the weights were the same, it's kind of random where it goes, right? But if you could adjust the sizes of the things where the ball hits, you could kind of make the ball go a certain direction. That's what you're doing when you adjust the weight. You're creating the different sizes for these pins in this ball. So you say, well, I want to make that pin larger, so I wanted to hit it to go over there. So you're adjusting the weights, so the input, you know what the output's going to be. But an LLM is not a search tool. Right? The first thing when someone uses an LLM, like ChatGPT or any of the other chatbots, they type in something like you'd type into Google. It's not a search tool. It is not a search tool. Can it be used in a search architecture? Of course. It is not a search tool. Right? I mean, there's a TV program in the US, like 60 Minutes. They had a thing about like people are typing into ChatGPT. It's not a search tool. It's a language model. So that's the first thing you have to understand. It is not a search tool. Can it be used with search? Yes, of course, of course. It recognizes text patterns and then it finds the most probabilistic next text. That's what it's doing. So you train it, right? You teach it. That's the machine learning part. And then you ask it to complete it using a prompt. So you sort of prompt it. That's where the word prompt comes from. You kind of, here, probably complete this for me. So this should be the first thing you type into ChatGPT to understand it. So what's called a completion model, you say rose are red, violets are, of course. Why does it answer blue? Because that was the most probabilistic thing in its memory, right? In this neural network, the most probable thing was blue. It didn't say violets are something else. It said they're blue. If you understand that, then you understand what an LLM does. Right? I didn't type in a question like what is, or who is, or what is the best, or who is the best baseball. No. It's completing my prompt. Okay. So the prompts steer the behavior of the LLM. Now this is important when you use an LLM, like in software development, whether it's in IntelliJ or what's that new one? There's another new AI IDE. You have to understand how to adjust your prompts to ask the right questions. Because when you use an LLM, think of it as a really smart intern. Like you're doing pair programming with an LLM. And sometimes the LLM gets confused and says, all right, start all over again. Think of it as another person that knows about the patterns. That's how you should treat an LLM. Not as like a search tool, but as a partner, right? And prompt results, of course, there's many LLMs these days, but they're all basically the same, whether you use Anthropic or ChatGPT or Google or whatever, they're pretty much the same. Okay, so you have to understand how to use prompts. So here's another completion prompt. You can type in, his Messi lines up free kick. He shoots and it fills it in because that's the patterns that it had. Right? That's the patterns that it had in its model. So there are REST APIs, and we're all familiar with REST APIs for this stuff. Like, OpenAI has them. They all have REST APIs. I think there's like native Python and native JavaScript, but all the rest are REST. All the rest are REST. and they're stateless calls, right? They're stateless calls. So the things on the right, okay, yeah, I understand that, stateless calls, whether it's in a Volkswagen. Believe it or not, Volkswagen has ChatGPT in the car. It's like, okay, kind of scary. But so they're stateless. But what's interesting, a chatbot, it's like, wait a minute, that has to have context. Like, that's still stateless. It's still stateless at the REST API layer. But somebody has to keep context, which I'll go through. So here's a real quick example. I did it in like a little shell thing, a little curl script, just so you can see it. So you get the key from OpenAI, like you get the key from any REST provider, right? You create an account. It's everything is relatively cheap except like GPT-4 is a little pricey, and then fine-tuning stuff is a little pricey. But if you use like GPT 3.5, it's dirt cheap. You know, I mean, I play around all month, and you spend like $1. So it's dirt cheap. I guess in the U.S. that's dirt cheap. So what's interesting is this thing in blue here. So there's like a little language that you send to the LLM. And they're messages, right? And here I'm just saying, give me a Java program that says hello world, right? So you get back, and actually I said JSON, yeah. So I said application JSON. So I get JSON code back, and the thing in red is a Java code. So that's effectively the communication you have with OpenAI or any other service. But how many models are available? How many models would you guess? Anybody? 100? Anyone else? There's almost 600,000 models.
Aren't those variants? Aren't those variants of the same model?
Not necessarily. There's vision models, there's audio models, there's text models, there's completion models, there's conversational models, there's text-to-speech model. So there's all these models, right? And this is, a few weeks ago. Actually, what is it? It's a few days ago. There's a lot of models. There's a lot of models. Now, let's talk a little bit about prompt techniques, because that's how that's the base level of interacting with an LLM, right? And of course, it's what's called prompt engineering. It's not really engineering like we know it, right? So I guess in a loose sense, because what's engineering? Engineering is not solving a problem, right? When someone says, what's engineering? Well, it's solving a problem. Well, not really. It's solving a problem within a set of constraints. That's engineering, right? Like we heard from the keynote. What are the trade-offs? What are the constraints? So you're solving a problem within constraints. That's engineering, right? So it's not really engineering. So these are techniques, okay? And we're still early days. So don't think like, if I don't learn it now, we're gonna be out. This is a multi-year, 10, 15-year trend. And it's still very, very, very early. Very early. So don't get like depressed when you see something, oh, this company's doing that company's doing that. It's early days. A lot of companies won't even touch the stuff now because they're worried about legal problems. Okay, so with prompt construction, you start simple, and when you're using ChatGPT, it's an iterative process. You talk to it like you're talking to a person. When you ask for code, you might say like, well, that doesn't compile because this. And he goes, oh, sorry, let me give you this. And he goes, well, you left out this dependency. Oh, yeah, sorry. So talk to it like you're talking to a human. It's just faster, right? And it helps you look up, things on any of your popular websites. And you give it instruction, how do you behave first? Well, okay, so behave like you're an expert Java developer and act in a friendly way. Give it some hints on how to behave, and also give it examples, give it context. Don't just ask a question. It has no context, right? And also, don't dwell on what not to do. So LLMs aren't good at negation. They're not good at negation. Tell it what to do. not what not to do. Like, don't do that. Give it. It's better when it does that. And there's some techniques. I'll just give you a few. There's several dozen. There's something called few shot. Few shot means no examples. Don't give me any examples. So here's explain generative AI. So I didn't give it any examples, and it gave me this whole thing about GenAI. Okay. There's another one called few shot. Few examples. So here I gave 4 lines, right? This is a fantastic product. That would be a 10. No one responded to my emails. That's a 0. Support was helpful. Give it a 3. Work okay. Very expensive. Give it a 5. Still waiting. What would you rate that in ChatGPT? Well, based on what you said, that it's a 2 and it's negative. So I gave it examples. I gave it context. It's important to give the LLM context. It works way better when you have context. And the context can build up when you have a conversation. And then here's something called chain of thought, which is popular, is that when I first was playing around with this stuff, I was told like, it's really bad at math. And I said, what? It's like it's running in the cloud with like all these GPUs. It's like, what do you mean it's bad at math? It's bad at math. It's a language system. It knows about language. And he goes, well, how does it do arithmetic? It knows about language. So you have to tell it. I mean, this is changing, as we speak. But you had to give it examples. Here's the thought process. And here's just one example, question and answer. You can give it multiple question and answers. Here's the thought process, here's the answer. Here's a brand new question, what's the answer? So you've given it more context, right? So you're not making it smarter or it's not searching harder. You're sort of like guiding it based upon what the LLM knows. You're sort of like prompting it, go this way, go that way, go this way. And there's many other techniques that you can, if you're interested, you dive down into that. And so the way that you structure a prompt is that you have the prompt what the user types in, that's the thing, that input, that the thing in orange. But then you have to give it context. Or maybe you want to give it like how to behave. Answer like I'm a 5-year-old. Explain quantum computing like I'm a 5-year-old. Which, wait a minute, where's that website? I could use it. And then give it examples. Then you give the prompt, and then you say, well, what output do you want? Do you want it in JSON? Do you want it in a different language? And it doesn't, I was told it doesn't matter with the order, but I found in practice it depends on the model. Sometimes the order should be like this, and sometimes it's not like this. So we're learning about these models. This is it's like a biological entity, and we're probing it to see how it behaves, right? I mean, even some of the AI engineers, like, we don't know how it does that. It's a little weird, but we don't know how it works. Let's get this emergent behavior. I don't know how it happened. It's a little scary. I mean, I worked on Wall Street, so how did derivatives work? We didn't know. Look what happened. Okay, so OpenAI services, you can go to the website and find that there's chat complete. There's a text completion like I showed you. There's chat completion. In other words, it's trained on conversations. Right? So it's trained on conversations. There's, we know about DALL-E and image generation. There's speech to text, text to speech. And there's two of these on the bottom, which I'll get to. How do you fine-tune an LLM for a specific use case, like for medical or finance or for coding, right? That's fine-tuning. And embeddings, we'll cover embeddings in a second, but that's how do you relate one piece of text to another piece of text? Okay, and there's the REST APIs for if you want to snap that picture. That's OpenAI's doc. Speaking of docs, do you have friends that are tech writers? They should worry about their jobs. Just like support people, they should worry about their jobs. So there are some places where you have to worry about your jobs. Okay, because there's a lot of software, this type of software will take over. But they'll create other jobs, right? Other types of jobs. We're already seeing that. So here's an example of, did I cover? Yeah, so here's an example of using OpenAI's, this is GPT 3.5. And what's interesting is the messages thing in the middle here, that little language. So here's the prompt. And I'm sending it as a user. It's like, write a joke about Java programmers. And the system prompt is telling it how to behave. Right? So you're an insult comic. It's not very insulting. It's just an insult comic. So in some LLMs don't have a specific message for a system. You just stick it into the user prompt. An OpenAI engineer told me they did that for security reasons. They wanted to separate system messages because they were worrying about prompt injection, bad prompt injection. So, and I'm not sure how well that worked. I mean, that probably will change in the future, but that was the intent with system messages, was to do it separately and to separate that to reduce the chance of prompt injection. All right, so there's three types of messages. The user messages, which makes sense, that's what the user wants. The system messages, system messages are how to behave. Now, system messages are, when you read this, it's like, that's the message that, wait a minute, that's coming back from the LLM. Well, it's coming back from the LLM, but then you could also send that message back to the LLM as context. So actually, I should have a double arrow on the system message. So a system is coming from the LLM, but you could save it and then send it back as part of the context.
Like a chat is sent back to the user.
Yeah, so I'm going to talk about that specifically. You're right. And so Java API. Well, it's a REST API, right? So, but finally we have a Java. So I started doing this a year ago, and it was GPT 3.0, and it's a REST API. It's how hard could it be? So I did that, and it worked fine. And then they came out with 3.5, and then all my code broke. Everything broke. And I said, what the heck? And I looked at, they changed the message format. They changed it, they changed that. I mean, somebody didn't know about API evolution, clearly. So 3.5 just blew up all my code. So I said, I got to do this all over again. Worry about this and the time that's like. So I said, yeah, okay, I'm a senior developer. What should I do? Find out who did this already and use that code. So this gentleman has a really good Java API for OpenAI. So that repo is really, really good. He did a very, very good job. So here's an example. And this is literally half a page of code, right? So you create a bunch of messages. Here's an array of messages. And your system message is that you're a funny comedian, you'll respond as one. And here's the user prompt. How should I learn Java? So you create those messages, and you add that to this list. And then you call ChatGPT. And here it's a little good old builder pattern. It's like, use the model 3.5 Turbo. There's my messages. Give me one completion. It turns out you can have multiple completions. You can say, give me 5 completions. I mean, there's a technique that you can say, give me a bunch of completions. Now send those completions to another LLM with some context. Give me the best one, and that's the one that I'll use. So there's collaborating LLMs. Max tokens is how the context window. It's like how big is, that's not the context window. That's restricted to this. Like I'm doing development, so I don't want to spend too much money. So I said 30 tokens, just for development, but that's normally a larger number. Could be like, 10K or 20K or something like that. Each model has its own max, so you just have to be aware of that. And then here, the service create, the last line there down the bottom. Call ChatGPT. Sure.
You had in the previous slide also, you had OpenAI.com as one purpose. All the code was terminating. The endpoint was OpenAI.com. Is it possible your Java code doesn't have the URL either? So is it possible to host that?
Oh, okay. So you don't want to call their service. You can host it. So they don't have a local, but if you go back a couple slides, there's 500,000 ones. Most of them you can run local. The Facebook one you can run local. So I have a class that I teach, and I don't know what laptops students have. So sometimes you need a certain laptop, so that's why I stuck with ChatGPT just to make it easy. But if you have a decent laptop, there's many models you can run. And if for ultimately private chatbots, you want to run inside your own data center, that's what you have to do.
So OpenAI is defining the REST interface.
Yes.
And you have a Java wrapper around
This gentleman's right.
And in that specification, in that REST specification, is it implied that the URL will be, our company is tied up?
Yeah, so his URL, I hesitate to say hard-coded, but his API, his repo uses those specific endpoints.
You cannot change.
Well, you can take his code.
So instead of using that code, if you look at like LangChain or some
Yeah, so I'm going to mention, so LangChain 4J is a really good, thanks for those people, that's great. There's other APIs to use, that's a really good one, LangChain 4J. Also, there's a talk this afternoon, Ken Cousin has a talk on APIs, you should go to that one too, that's really good. Okay, yeah, actually, here's LangChain 4J, thank you. I didn't pay this gentleman either, that's the next slide. Yes. All right, you have to wrestle now.
I'm saying that Spring also came up with
Yeah, so Spring has the Spring AI, right? So I need to talk to Josh about that. So that should be Spring GenAI. Does it cover predictive AI? I don't think so. And so why are you calling it Spring AI? It should be Spring GenAI. Because I'm the author of that JSR. Can you support my API there? No, so you can't call it Spring AI. I'm sorry. Yes.
So in our project, we have a couple of APIs which are GET APIs actually, and as you know, like the GET APIs don't have much of information. It's just hitting that endpoint, correct? And that endpoint is pretty much static always. There might be few.
Yeah. So they're static, right? The static endpoints, right?
I see a very great application here where I don't want the callers of my API to be too much worrying about the specification of my API. So in that context, can the caller just type a prompt and my backend system understand, hey, this person is trying to call this GET API?
And more sophisticated. Your question is, can I redirect the prompt to a different LLM? Of course you can. Right.
And does the LLM, is there a way for LLM to be in the context of my exposed APIs only?
So this is beyond API. So do all the LLMs behave the same way? I don't know. There's 500,000 of them. If you test now, send me an email in the morning and say if they work or not. There's a lot of them, right? So there are tools coming that will help that. Supposedly they work the same way, but if you're doing this in a production environment, you better test.
Exactly. So because if we achieve this, then the callers of my API don't have to always know the entire hard-coded link of my API, correct?
Yeah.
They can just type an equivalent query or a prompt that would be automatically routed to my API. And
these are things you have to worry about as a software developer, right? It's like there's a lot of questions. So let me continue because I'll get to that more in depth. So the chatbot architecture. So we know it's stateless, right? REST API stateless, but it's a conversation, right? A chatbot has a conversation with a person. So well, that's holding state, but it's stateless. So somebody has to hold a state. So who's doing that? Well, your app has to do that. So if you're building a chatbot, right, from scratch, not using any of the APIs out there from scratch, somebody has to hold a state. So if you're writing a program to do that, which hopefully we'll have time to show the demo, that you ask the LLM for something, right? You have some context, you get back a result. They take that, the user history, the assistant history, you put that in a new buffer, add the new prompt, send the whole thing over there, and then you get back a result. Get that, add that, and then so your buffer gets bigger and bigger and bigger. You're sending more and more stuff to the LLM, but you're giving it more context, conversation context. And you have to just be aware that you don't exceed the limit for that particular model. Or you have some algorithm that throws, like a caching thing that throws the oldest ones out. So what Chatbot is coming up with more context. It's building up context as you go, right? So that's how a chatbot works. It's pretty straightforward. It's in my class, we go through we have a chatbot class, and it builds up. It has user history and has assistant history, and then you generate the buffer that's sent. But it doesn't know anything about your private docs, right? It just knows about your conversation. So there's several ways to get an LLM to understand your docs. Okay, let's start at the very top. We went over prompt techniques, right? Prompt engineering, okay? That's when you see these articles on the future will be no code. Well, that's what they mean. They mean people that are using prompting. I think, who said the NVIDIA CEO says, like, it's the future going to be no code. Okay. All right, he's doing his thing. He's a salesperson, right? So, yeah. And then at the bottom, if you're one of the few people on the planet that can write your own LLM, you know about neural networks, like my friend Zoran can do this, you write your own LLM, right? And if you want to train your own model, say you take someone's code, and I'm going to train it on finance, like Bloomberg did, right? They took a basic model and they trained it on all the financial information they had. So they had their own model. But you have to be a data scientist. You have to know about statistics, right, and data science. And I know from all the thousands of students that I've had, most of them will never, ever, 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 ever be data scientists. They just, you have to know a lot about stats. If you're good at that stuff, you can do that. But you have to be a data scientist. Okay, so that's the bottom two. Actually, and the things in orange is that you're actually changing the weights inside the model. The weights I talked about originally in the first few slides, you're actually changing the weights in the model. The things in green are up here. You're not changing the weights. You're like at two different boxes. Okay, so then you train your own model, then you have fine-tuning. So fine-tuning is sort of like training your own model, but it's like you have a model, you trained a model. Fine-tuning says, I want to use that model, but I want to add some other stuff on it. It's called transfer learning in ML circles. It's called transfer learning. You have a model and you want to fine-tune it. So but you still have to be a data scientist. And it's still fairly expensive, right? You have to know what you're doing. Now, the second thing in green is something called retrieval augmented generation. So that's a better way of getting better results. And it's effectively a prompt technique. It's effectively a prompt technique. It doesn't change the weights in the model, but it's a way to steer the LLM to give you a good result. So those are the ways that you can get an LLM to understand your docs. Okay, so prompt techniques, they're fine, but they don't. The foundation model only knows about general internet, which is, I'm not sure if it's good or bad, but it knows about general internet. It doesn't know anything about my docs. It still hallucinates, which I always thought was a bad word. Delusional, I think, is a better word. And the foundation model is not updated in real time. I think OpenAI has a version of ChatGPT 4 that's updated fairly recently, but you have to pay a lot of money for it because it's expensive. I mean, it's bad for the environment too. You have to train, your model on large data and do it over and over again. It's very expensive, and you don't want to create your own model. It's just too costly. And you don't know anything about citations. Where'd you get this information? I don't know. It's like getting information on Facebook. You have to have citations, right? Give me a link where you got that from. Okay, and I'm not a data scientist. So here's RAG. So what RAG does in a nutshell. So way back in 2015, so Google, they created a model of a conversation, of a human conversation. Sounds kind of weird, but they created a model of a human conversation. They had to have this paper. So that was the base level paper. And then Facebook came along in 2020, or Facebook research, Facebook AI research came along, and they stood on their shoulders, right? That's what we all do. We stand on the shoulders of people before us. And they came up with something called RAG, or Retrieval Augmented Generation, which is taking the idea of a conversation, but using that in a context of an LLM. So what they do is that they take your parts of your docs and they put it into the context of the prompt before they send it to the LLM. So you're steering the LLM to give you better results. So here's the diagram, the basic diagram. So the user types in something upper left, generates a prompt, right? And then the first thing is that, well, what other docs or whatever strings do I have in my own data store that are similar to this question? I'm looking for something that are similar. And I'll talk about what the word similar means, but look for similar things. Take those similar things, maybe take the top 10, put them together in my prompt as context, and send that to the LLM. So you have chunks of your documentation, right? It could be your own API documentation or internal company stuff, and that you keep in a database. And so the LLM has more context to work on. So that's the basic RAG architecture. To put this in production, it's a little more difficult, but there's a lot of advantages, right? You get specific content, you reduce hallucinations, that whole thing about hallucination as we go in time, get better and better. You're in control of the data, you have citations, right? But the problem, and this is what's gonna happen over the next few years, is that to put it in production, there's a lot of crap you gotta deal with. And this is why a lot of companies won't put these things into production yet. There's so many problems to solve yet. We are in the early days. You should learn this stuff, but just be aware, we are in the early days. So you just can't put this in production right away. And I know there's some people that are tech writers, and their companies say, we're just gonna create a chatbot, and it's that's cool. We can get rid of tech writers. They went from being just writing text, good text, into deploying an application. That step is like this, right? We all know about putting stuff in production. So they went from here to here, and they didn't understand what they're doing. So there's a lot of things to worry about. So, but there's a lot of opportunity for startup companies to address some of these problems, right? Whenever you see problems, you shouldn't look at them as problems. Look at them as opportunities. If you want to have a startup company, it's like, well, I want to handle those things. The legal part, that's a big area. How do you handle regulatory things and legal problems with LLMs? Because this is a probabilistic techniques. IT is deterministic. We're dealing with probability now. The CEO gets a little worried when things are probabilistic. It's like, I want to know, I want to be deterministic. So there's still issues to resolve yet. Okay, so I'm going to breeze through some, because I really want to show some demos. So similarity. What does similarity mean? Okay, so RAG has to find out what similarity. So what is similarity? So let's take some music. So we have some music from different artists. And I heard Shake It Off is a very good Tay-Tay song. So if you wanted to find out how similar these songs are, what could you do first? Well, let's go by beats per minute, right? So we look at beats per minute. So if we go like Summertime, the Ella Fitzgerald, like Summertime's like, and then we have Highway Star. I listened to Highway Star when I used to run track in high school. But it's like, right? It's like that. But if you look at some of these, like you look at to the left, you have like Summertime and Basket Case. So you have like a pop punk song next to a jazz song, and they're only like 25 beats per minute away. Well, yes, they are similar, but not really that similar. So that's only one dimension. So let's take another dimension. Let's say like if you're more pop or rock or you're more jazz. So let's put them in a 2D space. So let's take two of those. I have So What, Miles Davis, one of my favorite musicians. And then we have Green Day, not one of my favorite musicians. And we can find out how similar they are. Sorry if you're a fan. And we know from high school geometry, we could find out how close they are, right? It's very simple to do that, which of course we've all forgotten that equation, how to do that. But that's how you find out if they're close. And when you say close, that means similar. When they're close to each other, that means they're similar. But that's only 2 dimensions. So I was going to draw something in multi-dimensions, but that was a joke. There's nobody, no math. So it's a very bad joke. So we can see things in 2 dimensions, 3 dimensions, but not in n dimensions. But for most things, you need multi-dimensions, right? So here's text. For OpenAI, here's a string, hello world. That's the embedding string, represents hello world. So there's 1,536 elements to that string. Pardon me?
Isn't that your choice? How many dimensions you choose?
This is the choice of the embedding service. Yeah, not my choice. So different embedding servers might give us a different size vector. All right, and here's Theo's in his repo. He has how do you get the embedding service. It's very, very straightforward. Okay, so now how do we determine similarity for when you have multi-dimensions, not just for 2? There's this equation. You say, oh my God, it's like how to, so what's the first thing you should do? Ask ChatGPT for the code, right? And then what's the next thing? Run it directly in your machine? No, of course not. You're crazy if you do that. You come up with a virtual machine, run it in a sandbox, take a look at the code. You should read the code, make sure it's doing what it says. Don't just run it like some people, some junior developers are just go, I'm just going to run the code machine. Look at the code. It's like, what are you doing? Common sense. Okay, so now where do we store the data? It's something called a vector database. So you can store it. You can store your private docs in some other database, but you have to figure out the embeddings. And some databases are not good for long vectors. We dealt with this in Wall Street for a long time. There are certain databases that are good for this, like relational is not good for this, but vector databases are good for storing vectors, hence the name. But in a database, you can store metadata. You can store where it came from. Well, what doc did I come from? What MP3 was that transcribed in? Where's that PDF? What website I came from? So then when you give a result, you can say, here's some citations that you should check out where I got the information. So save that in a database. And there's lots of these things. Most of them have Python APIs. I was using Milfus. It was how to put this politely, it was the least offensive Java API. So I use Milfus. I bug those guys all the time about their Java APIs. Okay, so you have to understand how to chunk this stuff in the database. And there's a whole thing about chunking. How do you break things up into sentences? Do you break things up into just words? Do you break things up into paragraphs? Do you break them into HTML, Markdown? It depends. Yes. Any question I say, that's the right answer. Yes. It depends, right? And maybe during a process of an app, it's different. You use different embeddings. Maybe you use that vector database, that collection, that table for some things. You use that table for something else. This is all early days. We're still learning about this stuff. Okay. And when I learned about this last year, I said, okay, here's a sentence parser. I parse a string into sentences. Once I had this, I mean, from decades of Java programming, so I know how to read all these things in great strings, right? So once I can do this, I can load my vector database. So I happen to use sentences in my demo. You can use paragraphs, you can use HTML, Markdown, whatever you want. But I just happened to hard code sentences when I was learning this. So that's I have a few minutes left. Any quick questions while yes?
Would you seem to be weighting the statistical impact of the LLM over the vector space from the embeddings? Like, are we assuming a standard normal curve? Like, I've been treating these more as a vector space and a statistical distribution.
Let's talk after that. That's a deeper question. Yeah, yeah. So
Are the slides? I keep them a bit blurry. Are the slides available
I can make the slides available, but I think Pratik and Vince said they would make them available. So here's a command. So let me run this guy. It'd be nice if I started a database. Okay. Let's see if I have connectivity. My little laptop, my poor little laptop. Yeah. Sometimes the database takes a little bit of time. All right, well, it's not cooperating. I know I'm running out of time, so whoops. Nope. All right, well, if you catch me during the day later on, or I could show you the whole demo, it's not behaving. But basically what I did is that I know my little laptop sometimes doesn't like me, but here's my little program. Like you say, here's an instruction. This is a system message. Okay, you're a Java expert. Create a table. They're called collections in the vector database. Give me the 10 top features of Java 22. It doesn't know what Java 22 is, right? It has no idea what Java 22 is. So then what my code does, it using some libraries that we all know and love. Load a website. Here's an InfoWorld article, recursive level 1. So don't read the entire website. You'll be here for 2 hours. So just read the first page. So I read that one. Read this other one, the release notes on Java 22. Only go down one level. Here's another one. So once I have those, yes.
Load website, is that a command native to your application?
That's my app. Yeah. So I'm gonna teach. Yeah. So I'm gonna put. You could look at my repo, but it's embarrassing code. So I'm gonna clean it up and I'm gonna clean it up because I have to teach a course on it in 3 weeks. So I'm gonna clean up and put the repo there, and I'll tweet it out so everybody has it. So then once I did that, okay, and I said, give me the top 10 features of Java 22, and it gave me 10 features. Right, so I could have, and then what I wanted to show you is that I could change the speaking language. I said, now speak to me in Italian, or speak to me in French, and it's like, and I tested that by asking friends, and they said it's perfect translation.
You didn't have to give it in Italian.
No, it was surprisingly good translation. And I also did some, since I'm a guitar player, I took one of my favorite guitarists, I looked at all his tutorials, I did an MP3, got the transcriptions, fed them all into his particular table, and then I had a voice synthesis in his voice, since I was able to get his voice, and he was able to answer me my questions. Like, that's pretty cool. That's really cool, and it didn't take that much code to do. So there's a lot of stuff here. I'm sorry my little laptop didn't cooperate, but thank you very much for coming. I'll be around.